Hello, my name is Sarah Wienke. Today I'm going to investigate the relationship between breast cancer and oral contraceptive use by reviewing 3 research articles. These articles were discovered by using the PubMed database made available by the University of Kansas Medical Center Library. Articles were chosen if they were original articles published after 2000, peer-reviewed, and not a review or meta-analysis. The exposure being examined today is oral contraceptive use. Many women decided to utilize different contraceptive methods for various reasons. Of those methods, one of the most popular choices for birth control is oral contraception. As you can see here, 79.3% of all women who have had intercourse choose to use oral contraceptives as their choice of birth control, and 15.9% of these women aged 15 to 44 use oral contraceptives. The outcome being addressed today is breast cancer. In general, cancer is the second leading cause of death among American women, only after heart disease. Breast cancer is a complex disease with many factors playing into its development. Basically, these factors can be divided into 2 categories: uncontrollable risk factors and controllable risk factors. Uncontrollable risk factors include things such as genetics, breast density, and family history, while controllable risk factors include domains such as alcohol consumption, being overweight/obese, being physically inactive, not having children or breastfeeding, hormone replacement therapy, and birth control. While oral contraceptives have been shown to slightly increase breast cancer risk, the risk seems to return to normal after approximately 10 years after discontinuing use. Article 1, titled Lifetime Cancer Risk and Combined Oral Contraceptives, the Royal College of General Practitioners Oral Contraception Study by Iverson et al., set out to evaluate the very long-term cancer risks and benefits associated with the use of combined oral contraception, which included breast cancer. This was a prospective cohort study that included 46,022 women from the United Kingdom who were recruited by their general practitioners between 1968 and 1969 and then were followed for up to 44 years. Exposure was measured by pill status, meaning those who were ever users and never users. This data was supplied by the general practitioners. The outcome was measured by cancer incidence and was identified by central cancer registries. The results showed a weak attributable risk of breast cancer that dissipated over time. Article 2 is a case control study titled Recent Oral Contraceptive Use by Formulation and Breast Cancer Risk Among Women 20 to 49 years of age by Baber et al. The aim of this study was to evaluate recent use of contemporary oral contraceptive formulations. This study included 1,102 American women aged 20 to 49 and took place from January 1990 to October 2009. The exposure was defined as oral contraceptive users, non-users, and former users, and was pulled from the Group Health Cooperative Electronic Pharmacy Database. Breast cancer incidence was the outcome being measured and was identified by CSS. The result of the study supports that oral contraceptive use increases breast cancer risk. The final article, The Relationship Between Breast Cancer and Oral Contraceptive Use Among Thai Premenopausal Women, a Case Control Study, addresses exactly what the title says it does. The study population included Thai premenopausal women under the age of 45 from November 2013 through December 2014. The exposure of oral contraceptive users and non-users were identified by means of a questionnaire, and the outcome of breast cancer was identified by pathological and lab testing. These results also supported that oral contraceptive use increases breast cancer risk. Next, we will address the strengths and limitations of each of these studies. Since Study 1 was a prospective cohort study, it was important for them to have a large cohort population since the cohort studies are prone to large loss to follow-ups. This is due to their long duration. Fortunately, the study did have a large cohort population, but were also limited by a large loss to follow-up. Another strength was that this study had a long follow-up period. This really allowed them to explore the long-term effects of oral contraception and cancer risk. Lastly, systematic differences were unlikely due to the use of cancer registries. One limitation of this study is that it did not include women with chronic illness. Since cancer is classified as a chronic illness, and many other people suffer from other chronic illnesses such as diabetes, therefore, this might not be a true sample of the population. Other limitations include lack of data about potential confounds and that hormone content was not accounted for. Moving on to study 2, there were several strengths that enhanced the credibility of this study. For starters, their utilization of an electronic pharmacy database decreased misclassification. This study also had a large number of controls, equal opportunity screening, and electric mammography allowed for extra breast cancer diagnosis. Lastly, there was no direct contact required, which helps decrease interviewer bias and other confounding variables. Study 2 also had a couple limitations. These included relatively short duration of enrollment, as well as the same issues of not having data on potentially relevant compounds. Study 3's strengths include reducing classification bias due to the pathologist diagnosing and confirming breast cancer, and that they had easily identifiable and sufficient data provided by the National Cancer Institute. Weaknesses included that it was a hospital-based study. This means that this sample was not representative of the population. The study also had difficulty selecting suitable controls. Next, we will address the Heineken's criteria for each study, which is used to identify the strength of a cause and effect relationship. The more criteria that is met, the stronger the cause and effect relationship. There are 7 criteria, and they include chance, bias, confounding, strength of association, biologic plausibility, consistency, temporality, and dose response. Chance is used to identify if the data is statistically significant or not. If the confidence interval includes 1, then it is not statistically significant. This study measured at a 99% confidence interval that was equal to 0.91 to 1.17. Because this range includes 1, it is not statistically significant. Bias occurs where there is a prejudice in favor or against something. In this case, there is a chance that information bias occurred because of the confidence intervals as well as the results of the previous studies. Confounding variables occur when something other than the exposure is causing the outcome. Researchers use controls to eliminate potential confounds. Here I included ones that were mentioned in the study as well as some that were mentioned in the other reviewed studies to allow for comparison. Next, the strength of association is used to interpret the strength of the relationship. A weak association is considered to be between 1.01 to 1.5. This study found a weak association of an incidence rate ratio of 1.04. Since this association was weak, the researchers calculated the attributable risk, which was 3%. This means the oral contraceptive use gives about a 3% increase of breast cancer. Biologic plausibility looks to see if there's a biological possibility that the exposure is causing the outcome, and the study does indeed show some biologic plausibility. Consistency refers to how a study compares to other studies. Even though it is weak, research across the board has been showing a slightly elevated risk of breast cancer related to recent oral contraceptive use, and the study is no different. This can also be illustrated by comparing it to the other 3 studies. Temporality refers to the time frame of the study, specifically that the exposure occurred before the outcome. Since this is a prospective cohort study, the exposure definitely occurred before the outcome, unless the outcome was not witnessed at all. Lastly, dose response is a measure of the amount of exposure. Since the study fails to place the population of the study in subgroups based on the amount of exposure, dose response criteria is not met. This study calculated their chance results at a 95% confidence interval in which they got 1.3 to 1.9 for recent users. Because this range does not include 1, it is statistically significant. In this section, I also include the data to support the dose-response criteria. I believe that selection bias could have occurred in this study because it was a matched case control study. Matching means researchers hand-pick controls based off of certain confounds to match their cases to best balance out the study. This study used odds ratios for their strength of association measurement with a result of 1.5. An odds ratio of 1.5 to 3.0 indicates a moderate association. Therefore, it falls within that criterion. Something I found particularly interesting was the subgroup with the least exposure had the weakest association, while the subgroup with more exposure had a strong association. This statistic really illustrates the dose response of the exposure. Biologic plausibility, consistency, temporality, and dose response criteria were also all met for this study. Study 3 also addressed chance with a 95% confidence interval, but this one ranged from 1.99 to 5.75. One nice feature of this study was that it included p-values, which for this figure was statistically significant. Confidence intervals and p-values were also included here to support the dose-response criteria. This study, however, did indeed have selection bias due to the fact that this study was based in a hospital. Therefore, it cannot be a true representation of the population. This study calculated the adjusted odds ratio, which was 3.39. Odds ratios between 3.0 and 10.0 indicate a strong association. Therefore, this study shows a strong relationship between the exposure and the outcome. Something different about this study is that it showed a weak association for oral contraceptive use from years 1 to 5 of use, then to a strong association from 6 to 10 years of oral contraceptive use, followed by returning back to a weak association from 10 or more years of use. Even though it is always associated with some increased risk, it would be interesting to get more research on this effect. The remaining of the Heineken's criteria for the study was also met. In conclusion, all three studies suggest an increased risk of breast cancer among oral contraceptive users, as well as recent and prolonged uses showing higher risks of breast cancer. Future research endeavors should further investigate the effects of different types of doses of oral contraceptives, as well as potential carcinogenic effects of other types of contraceptive methods. Women have many choices when it comes to contraception, and it is important that they have the knowledge available to choose which form is most healthy for them. In closing, here's a list of my references. Thank you for listening. I hope you found this literature interesting and informative just as I did.